Welcome you all to part 7 of Nuclei, that is nuclear energy. If you burn 1 kg of coal, it releases 10 raised to 7 joules of energy, whereas fission of 1 kg of uranium releases 10 raised to 14 joules of energy. It means that the fission of uranium releases energy million times more than the energy released by burning of coal. That huge amount of energy which is released is called as nuclear energy. Always in a nuclear reaction, energy is released and that energy is called as nuclear energy. And how is that energy released? That will be the session of today, and let us understand about that now. Okay, well, this is a binding energy curve. We had divided into 3 categories. One is lighter nuclei, one is middle nuclei, and another one is heavier nuclei. By this curve, we came to know that middle nuclei are more stable compared to lighter and heavier nuclei. And these less stable nuclei always wants to become more stable. And in this process, heavier nucleus splits into 2 lighter nuclei, so that these light nuclei will be more stable than this nucleus. And this process is called as nuclear fission. Similarly, 2 lighter nuclei combines to form heavier nucleus, and this nucleus will be more stable compared to these 2 nuclei, and this process is called as nuclear fusion. And in these 2 processes, a large amount of energy is released, because a nucleus with less binding energy converts into a nucleus with a high binding energy, and in this process energy is released, and that energy is called as nuclear energy. And we'll be understanding about these 2 in detail now. Let's begin with the nuclear fission. Nuclear fission is a process in which heavy nucleus splits into 2 lighter nuclei, releasing a large amount of energy. And how it releases, let us check it out. So first we will be taking a heavy nucleus, that is uranium-235. It is hit by a slow moving neutron which is having less energy. It absorbs heat from the surroundings and go ahead. That's why this kind of neutron is also called as thermal neutron. When this thermal neutron hits uranium-235, it converts into uranium-236. Means this nucleus absorbs that neutron. Right? It is possible, since we are taking low energy neutron. If you had taken fast moving neutron, then it would not be possible. That's why we will be using slow moving neutrons in this fission. And this unstable nucleus which is formed, it is splits into 2 lighter nuclei which are of comparable in size. One is barium and another one is krypton. And also 3 neutrons are released. And in this process, energy is released. And how much is that energy released? Let us check it out. Uranium, when it is hit by a slow moving neutron, it converts into barium, krypton. 3 neutrons are released. With that, energy is also released. How much is that energy released? 200 mega electron volt. And how is that energy released? Let us check it out. This energy is released due to mass defect. If you take the masses of uranium and neutron, and if you add that, that sum will not be equal to sum of masses of barium, krypton and 3 neutrons. And the mass defect which arises here, that converts into energy according to Einstein's mass energy relation. And how much is that energy? 200 mega electron volt. Do think, if you consider the splitting of only one single uranium, it converts into 200 mega electron volt. But in a sample, there will be large amount of uranium, and that is how large amount of energy is released. The neutrons which are released in this reaction again splits the neighboring uranium nucleus, and again the lighter nucleus are formed, and again neutrons are also released. That is how number of neutrons goes on increasing the number of fission. That is why this nuclear fission is also called as chain reaction. And this chain reaction can be controlled by controlling the number of neutrons. If you control that, then it is called as controlled nuclear fission chain reaction. If you cannot control the number of neutrons, it is called as uncontrolled nuclear fission chain reaction. Controlled nuclear fission chain reaction can be seen in nuclear reactor, where electricity is generated. That we'll be seeing in the next session here. In uncontrolled nuclear chain reaction, in which neutrons cannot be controlled, that you can see in atom bombs, where number of neutrons cannot be controlled, hence fission also cannot be controlled when it starts now. Okay, now let us start with the next session, that is nuclear reactor. Nuclear reactor is an arrangement in which chain reaction is controlled, And the principle used here is controlled nuclear fission chain reaction. And the schematic diagram of a nuclear reactor is like this. It consists of a core in which a nuclear fission chain reaction takes place. It consists of a fuel which is made up of a material of fissile isotope. During nuclear fission chain reaction, neutrons are emitted. Those neutrons are fast moving neutrons. But to continue nuclear fission, we need slow moving neutrons. And there should be material in the core which slows down the fast moving neutrons. And that material is moderator. We can use water, heavy water or graphite as a moderator. The energy which is generated in the core need to be transferred to steam generator, and that work is done by a coolant. Here heavy water can be used as a coolant. When water is passed to the steam generator, it converts into steam, and that steam is used to turn turbine, and that is how electricity is generated. To control the rate of fission, we will be using control rods, which are made up of a material which can absorb the neutron, because we know that chain reaction is possible due to neutrons. If you control the number of neutrons, chain reactions can be controlled, and that is how we can control this chain reaction by using control rods. And this is how the electricity is generated in a nuclear reactor. Now let us move on to nuclear fusion. Nuclear fusion is a process in which two lighter nuclei combine to form heavy nucleus, releasing a large amount of energy. But to combine these two lighter nuclei is not that simple, because these nuclei are positively charged. When they are brought together, there exists Coulomb's repulsive force. That is the reason why nuclear fusion takes place only at higher temperature, for about 10⁹ Kelvin. At this temperature, nuclei will get kinetic energy which can overcome the Coulomb's repulsive force. That is the reason nuclear fusion is called as thermonuclear reaction, because it takes place only at high temperature. And at this high temperature, two lighter nuclei combine to form heavy nucleus, releasing a large amount of energy. And this energy is released due to mass defect which has arisen in this reaction. And the energy released is about 24 mega electron volt. When we compare with per fission, it was about 200 mega electron volts. Right? When we consider per fission and per fusion releases more energy compared to per fusion. But when we consider energy released per unit mass of nuclear fusion is more compared to that of nuclear fission per unit mass. Right? So this was all about nuclear fission and nuclear fusion. Thank you.